If you've ever watched a bag counter on a packing line tick up one by one, or seen a batch cycle stop itself automatically after so many repeats, that's a counter instruction. Today, CTU and CTD, and the reset trap that catches almost every beginner. Quick distinction before we start: timers measure elapsed time. Counters count discrete events, pulses. Every time the input transitions from false to true, that's one count. It doesn't matter how long the input stays true, a counter only cares about that transition, that single pulse edge. CTU, count up, is the one you'll use most. Every time the input contact transitions from open to closed, the accumulated count goes up by 1. Once that count reaches the preset value, the done bit turns on. Real example: a bagging line has a photo eye that pulses once per bag. Wire that pulse into a CTU with a preset of 50. Once 50 bags have passed, the done bit trips, maybe that stops the line for a pallet change, or increments a batch total on the HMI. Important detail: the counter keeps counting up. If the input keeps pulsing after it hits 50, it goes to 51, 52, and so on. It doesn't stop or roll over automatically. The done bit just stays on. You need explicit logic to reset it, which is where beginners usually get tripped up. Here's the trap: a CTU has no built-in way to go back to zero on its own, unlike, say, a ton timer, which resets itself the moment its input drops. A counter's accumulated value stays exactly where it is, forever, until you explicitly reset it, even through a program restart, on many platforms, since counter data is often retentive by default. So every CTU you build needs a deliberate reset instruction somewhere, a separate rung with a res instruction, tied to whatever condition should zero it out. For our bagging line, that might be an operator pressed, new pallet, button, or an automatic reset the instant the done bit turns on, if you want it to immediately start counting the next batch of 50. Forgetting the reset rung is probably the single most common counter mistake. The logic looks like it works in testing, then a week later the count is sitting at 300 and nobody knows why. CTD, countdown, works in reverse. Each pulse decreases the accumulated value by 1 instead of increasing it. You'll see this used for things like tracking remaining cycles in a countdown, say, a batch mixer that needs exactly 10 mix cycles, and you want the display counting down, 9, 8, 7, so the operator can see how many are left. In many PLC platforms, CTU and CTD are actually paired together, sharing the same accumulator. Count up on one input, count down on another, and the combined value reflects both. That's useful for something like tracking parts in a buffer. Count up when a part enters, count down when a part leaves, and the accumulator tells you how many are sitting in the buffer right now. Here's a combined example you'll actually recognize: an accumulation buffer between two conveyors. An entry photo eye pulses the CTU side every time a bag enters the buffer. An exit photo eye pulses the CTD side every time a bag leaves. The net accumulator value tells you, in real time, how many bags are sitting in that buffer, without a single timer involved, just counted pulses in and out. Quick recap: CTU counts up on each pulse, done bit trips at preset, and it will not reset itself. You must build that reset rung deliberately. CTD counts down, often sharing an accumulator with a paired CTU. Together they're how PLCs track discrete events, bags, cycles, parts in a buffer, instead of elapsed time. Next video, we'll build a sequential motor interlock, starting and stopping a chain of conveyors in the correct order. First to last and last to first, using everything we've covered so far: contacts, seal-in, timers, and now counters. Subscribe so you don't miss it.